Hey, course 3, if we're dealing with adding and subtracting units that have mixed measures, we just have to remember what those measures are actually standing for, what they're worth. If we're adding up times, like 27 minutes and 15 seconds with something like 48 minutes and 42 minutes and seconds, we have to remember what this is in relation to this, okay? Minutes per second, maybe you just write a little reminder over here. There are, seconds per minute, 60 seconds for 1 minute. And we always put the smaller measure to the right. So it's 27 minutes and 15 seconds. Let's add up these separate like this, okay? So 15 plus 28 plus 53. 13, 16, 9, 96 here. Okay. 17, 1, 11 here. Now, I have 117 minutes and 96 seconds. I can't leave it there because we don't count seconds over 60 because 60 seconds is worth a minute. So we steal 60 seconds and we put it over into the minutes, right? Put it over here. Well, it becomes what? It becomes 1 minute when you go over to the other side, because 60 seconds is worth 1 minute. So we adapt the units here. Now I take that 60 seconds off I took off, and I'm under 60 now, so I can use that. 118 minutes, 36 seconds. Junior weighed 7 pounds, 12 ounces. Now he weighs 12 pounds, 5 ounces. How much has his weight changed, gained? Change is difference, subtraction. And he's always going to weigh more later than he did at the beginning. But it doesn't always happen that this unit over here is bigger on top, right? Because we've got all this over here to make the top bigger in all, but 5 ounces. How do I take 12 away from 5 as I work on this? Borrowing, right? We've worked on this before. So we need to change 12 into 11, but this is where things change, okay? What are pounds to ounces? Because this is ounces over here. 1 pound, the bigger measure, is worth 16 of these little guys. So that means this becomes 5 plus 16, right? Or 21, right? This is really 21. Minus 12 is 9. Then don't forget this was 11 now, so it's 4 pounds, 9 ounces, okay? So just big thing is remembering when you're borrowing what you now carry over. Now with a word on polynomials, polynomials are a group, an algebraic expression basically, that might have terms inside that include variables or numbers. It's basically everything we've been working with in algebra type parts of our course 3 lessons. And a polynomial where you just have one term, that's called a monomial because mono means one. So for example, 2x to the third is just one term. It's 2x to the third, that's it. It's not, basically, you have more than one term when you see a plus or minus sign. That's linking more than one together. But there's this one here, but there's nothing linking it to anything. It's just negative 5. These are all separate terms. They're all monomials of their own, right? Monomials. Even though there's 7 xyz's, it's all linked together by multiplication. So it's a monomial, or 1. Binomial, as we know about like bicycles, means there's 2 terms. So 1, 2. These are all kind of scrunched together a little bit, so it's hard to tell, but these are all the separate binomials. And a trinomial looks like this because we've got, right, 1, 2, 3 linked by adding and subtracting. They're all called polynomials. Poly means many. The degree, what we call the degree of a polynomial, is the highest exponent. So this is a degree of 2. This right here, this is a hidden 1, right? So this is a degree of 1 versus this one's a degree of 2. Degree of 3 right here. All right. Quadratic is when you have a second degree term. That's what we call those. If a term has more than one variable, the degree of the term is the sum of the exponents. So for AC, this is a good reminder. I don't think I remember this. Really, this is a 1 and a 1. So the degree of this monomial is actually 2. That's good. What's the degree of this binomial? What's the degree? This has a 1, and this has a... Sorry, we don't count the constants. 2. A to the second, so it's a degree of 2 versus this one's a degree of 1. And 5ABC, that's 3 variables, so 3. Highest degree of the terms in the polynomial. Looking at those variables. So in letter A, the term is, the degree is 3, because that's the highest exponent. In B, it's 2. And in C, it's just 1, because both variables only have 1, so we just pick, they're tied, so 1. That's called degree of a polynomial. We try to arrange them biggest to smallest, so it's like big here, and then it gets smaller as you go down in degree. That's called descending order, right? Because you're going down, 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 down. So if I have to rearrange this, I put this first because it's got the highest degree. It's a degree of 3 for this trinomial. Then I put this in second place, and this in third, and then constants always go last right here, right? If you want to add binomials, you check for all common or like terms. I see x's here, so I can add those to make 3 x's. 1x and 2x is 3x. So I'm having an issue here. There you go. And then I see 6 and negative 3. So that's minus 3. No, plus 3. Excuse me. Let's see how we did. 6x plus 3. I meant 3x plus 3. That's my bad. That's what I wrote before. All right, why don't you try A or B? D or E? And G through K, because those are quick, as long as